My architecture in Java remote method invocation. See another diagram of RMI architecture. RMI gives a way for Java program on one machine to interact with object residing on different JVMs. The important blocks of RMI architecture are stub classes, skeleton classes, and object serialization. RMI needs a layered architecture where each of the layers may be enhanced without affecting other layers. Layers may be defined as this: application layer, a server, and the client program. Skeleton and stub layer, intercept method invokes made by the client and redirect these calls to remote RMI service. Remote reference layer, setups connection to remote address spaces, understand and manages connection, how to manage, interpret references given from clients to the remote service objects. Transport layer, based on the TCP/IP connections between operating system in the network, it gives a basic connectivity as well as some firewall penetration goals. RMI stub classes give a reference to a skeleton object located in a different address space on the different or same machine. This is typical example of proxy design pattern, which builds an object executing another JVM seems like a local object. In JDK 5.0 and later, RMI facility access dynamic proxy instead of generated stubs, which build RMI easier to use. Here you can see client object looks up the stub in RMI registry and OGNID server, and RMI registry returns a stub to client object. Then stub method call on remote server objects on skeleton, and skeleton send result and exception to stub. And here you can see the client and server is connected through cloud or network. Client is connected to the client process. Inside the client process you can see a client object, stub, and remote reference manager. Client object is connected, interact with stub. Stub interact with remote reference manager. And here you can see the server process. It has a RMI registry, remote object, skeleton, and remote reference manager. Remote reference manager in client process is connected through RMI transport layer to remote reference manager in server process, and remote reference manager interacts with skeleton interacts with remote objects. And here you can see load stubs to RMI registry, and server is connected to server process. Here the note steps 4 and 5 are logical explanation only. Neither the stubs nor skeletons use sockets directly. The actual calls are made through the remote reference manager. Remote reference manager handles the actual details of communicating with remote process. This extra layer manages network communication and conserve scarce resources like sockets. Here you can see program 1 stub is connected to the skeleton, program 2 stub is connected to skeleton in program 1. Now this is the end of my presentation. Thank you very much for watching it.